Good afternoon. I'm Rocky Capozzi. On behalf of the Alaska Public Media and the Alaskan Aviation Safety Foundation, welcome to Hangar Flying. Our guest this afternoon is retired UAA professor Michael Buckland. Michael served as a designated flight examiner for 25 years. He has about 12,000 flight hours, and about 2,000 of those hours are on seaplanes. He holds an airline transport pilot rating for both airplanes and helicopters, and at one time he taught for the American Airlines Flight Academy. Our topic for today, Michael, is practical aerodynamics. Now, I know sometimes when people hear the term aerodynamics, in their head they're seeing thick textbooks and a lot of math. What do you mean when you say practical aerodynamics? What's the concept?
Well, it's true. It brings to mind images of people with Coke bottle glasses that can't get a date when they're in school. But practical aerodynamics is really about getting along with your airplane and about getting along with the laws of physics so that we can make informed piloting decisions and get back home safely with our passengers not having too many cheap thrills or excitement.
Okay, well, that's always a good goal. So how would a pilot apply practical aerodynamics?
Well, flying really is about the physics of flight. I'd like to say that the federal aviation regulations are printed differently than other government regulations because they're printed in blood. We learn a lot and we adjust the regulations over the decades because of accidents, and sometimes those accidents happen just because pilots might be making demands of their aircraft that the aircraft cannot, under the laws of physics, get along with, or it's not going to work well for them.
Okay, so can you give an example of an application of practical aerodynamics?
Certainly. Let's take a formula that we probably heard back in middle school, that the A equals pi r squared. The area of a circle is equal to pi times the radius squared. We made little jokes about pi r not squared, pi r round, mostly because in middle school the humor tends not to be overly sophisticated. But when a pilot is out flying, there's always concern, especially in Alaska, about where you're going to land should there be an engine failure, Rocky. And if you take pilot A, who's operating at 500 feet above ground level, and then pilot B is operating under the same circumstances, the same type of aircraft nearby, at 1,000 feet above ground level. Well, pilot B, being twice as high over the ground, is going to be able to glide twice as far. That's not rocket science. We could all probably figure that out. But what we forget is that the gliding distance is going to be the radius squared, determining the available landing area. In other words, roughly a circle. And so with twice the altitude, a pilot will have not twice the landing options, but 4 times. Under the same circumstances, a pilot operating at 2,000 feet, Rocky, would actually have not 4 times greater choice of landing areas, but 16. Your safety is increasing and your options are increasing as the square of your altitude.
Good point. Good point. So another good reason not to fly low all the time. Mm-hmm. Okay. How about, can you provide an example related to aircraft speed?
Absolutely. We could look back to the Hebrew prophet Throgmorton, who may have said at some point, "Maintain thine airspeed, lest the earth rise up and smite thee." An awful lot of aircraft have had accidents, sometimes very bad ones, in Alaska and of course in other places, simply because of a failure to attain and maintain proper flying speed. What it goes back to, there are certain laws of the universe, and one of them is going to be E equals V squared. That energy in the universe always is going to vary at the square of the velocity. So, as a simple example, if you hit an object with twice the speed or twice the velocity, you're going to hit it with 4 times the impact violence. And this becomes really important in a dozen different areas of handling aircraft, that as the velocity changes, the result is going to be changing at the square.
Yeah, good point. Now, one of the principles that we're all taught as brand new pilots is If you have an engine failure, you immediately pitch for your best glide speed. Do you maintain that best glide speed all the way to the ground, or when is it appropriate to change?
Not necessarily, Rocky, because the significance of VG, or best glide speed, it gives us the best chance of reaching a particular area, such as an open area clearing, a frozen lake on which we might land. So we're trained to maintain best glide speed. So let's take a typical example on how a pilot could use it. The stalling speed, or a safe margin above stalling speed, might be 50. So in our next segment, I think we can look at that a little more in detail.
Okay, good. I am looking forward to continuing this in another segment, so we hope to have you back soon.
Thank you for having me, sir.